Hello. Let me check the connection. I think you have to see me now. The webinar about object-oriented programming. There's something blinking here. Do you see the screen like stable? Let me check the... okay. So we'll discuss the operator new, which I wrote an article about a few months ago, and I also mentioned it in the Elegant Objects book. I said there that it's a dangerous operator. It's something which you have to be very careful about. So now we'll have two parts of this webinar. First, I'll give you some theoretical part, which I'll try to explain what I mean by the problem with the new operator. And on the second part, we'll do a quite quick, about 20 minutes live coding. So I will take a piece of real code and I will try to remove the new operator from it. Not remove it from the class, but remove it from the method. So here's the problem. This is not something which I invented. I just found it in many sources and books, and the problem is called the dependency injection problem, or just the problem of dependencies. So any class, let me show you some class first. So this is like really simple, piece of code. It's just one class of one attribute and just one method. So here you can see that the class depends on many other classes. So it cannot work by itself. Like really very rare classes in any languages can just work by themselves. They need other objects. They need other, the objects of their objects need other objects in order to function properly. Like in this case, look, we need, we need an item to do something, then we need a path, then we need an input. So we need other objects, we manipulate with the objects in order to produce some result, which we return here. That's obvious. We all need objects. But the question is where those objects will be created. So who will create them and when? In this case, one object is coming in when we instantiate the class RD resources. So in order to make an instance, we need to provide a project. We need to provide an object through the constructor. And then when the object comes in, it gets encapsulated, and then we manipulate it, then we touch it, we get something out of it, and then we manipulate it. But aside from that, this is really cool. When we inject something from the constructor, this is how it should be. But on top of that, we have many other objects which we create right inside the methods by the help of the operator new. So we call new here, there are many places, 1, 2, 3, 4, 5, like 6 times or more, we are using operator new in order to create other objects. So what is the problem with that? It looks quite convenient, you don't see, this code is okay, it's not a bad code. But the problem is the testability of this code and reusability. I think it's both, two problems. First, testability, second, reusability, or the other way around. So the question is, how can we reuse this class and how can we test it? So if you look, I'm not sure I have to test for it, but let me... No, we don't have a test for this class. That's exactly my point. So, but this class is quite testable. This class is testable. But in many other cases, when we use operator new inside the methods of the class, we make it difficult or sometimes impossible to reuse the class because it is hardwired to very specific set of classes which the class uses, which the class instantiates in order to perform what it has to perform. So here, in order to read the data, I'm using the input of from Cactus. Here, in order to create the source, I'm using stream source from JDK. Here I'm using new input stream off from Cactus again to create the stream, to convert the text into the stream. And as long as these classes are quite simple and quite, quite primitive, to be honest, everything is fine. But if they become bigger, these dependencies, so these guys are called dependencies. So this class depends on them and needs them in order to perform what it has to do. The more dependencies we have, the bigger the problem of reusability and testability. Because in order to write a unit test, we need to find a way how to break the connection between our class and those dependencies. Why do we need to break that? Because sometimes, and quite often, these guys, these dependencies, may connect us to some resources, to some really expensive resources, which we may not have at the time of testing, like databases, like production files, like production configuration data. I don't know, something which exists only when the product is works where we want it to work, where it was designed to work. But when somebody is trying to use it somewhere else or to test it, because using somewhere else and testing, it's quite similar. Because when you're testing, you're actually using your class in a different environment, different from what it's supposed to be used in production. So this class, when it goes to production, it will do what it has to do with all these input streams, and it assumes that well, in this case it's okay, because all these classes are like, that was my point. I wanted to say that all these classes are like supplementary. These objects they create, the objects we instantiate here, they don't really represent any expensive resources or any expensive dependencies. They are quite supplementary. It's like I want to show you another example. It's like something. Let me find some code. Yeah, this one. So let's look at this method, toString. So this method is building a text, and in order to build a text, it uses string builder. So string builder, again, we created inside the method, so it definitely is a dependency for us. So this method depends on the class string builder. But string builder is a representative of a piece of memory. So it's really cheap resource. Memory is the cheap resource, the cheapest probably resource. Maybe the CPU is the cheapest resource, but the piece of memory is probably the second resource after the CPU. So we can reuse this method anywhere we want. We can use it in unit testing. We can get this class and use it somewhere else. And we don't really want this method to work with anything else aside from string builder. So string builder is fine for us because it's cheap. But some resources are more expensive, and the more expensive they are, the more difficult it becomes to test the class. I'll show you another example, which we're going to refactor now. This one. So this is the implementation of quite primitive interface quotes. Let me show you the interface. Yeah, here's the interface. It's just an interface of one method, and the method says get quote. So it is supposed to return to get one currency in, another currency in, and return back the exchange rate. So how much would it be for $1 to convert it to €1? It's for financial transactions. This entire code base is the Xerocracy core platform. So we sometimes convert inside Xerocracy. We convert rates of programmers who work with us from one currency to another currency. And we need this interface in order to do the conversion when it's time to decide how much to pay. So we call this method quote, and we expect some double to return to come back. So the question is, where do I get the quote? Because every time we need the real quote from the market. And the market is something quite expensive. So we don't have this information in memory. I don't have this information in file. I need to go somewhere I need to make an HTTP request to some currency exchange platform and get the rate from there. So in order to do that, I designed, a few years ago, I designed a class which is supposed to work with the platform called, yeah, it was Get Exchange Rates, but yeah, I think, yeah, you see the name of the class is getexchangerates.com. That's why GER quotes, but in reality it connects to something else. In reality it connects to this API layer.net and gets the information from there. So here's what's happening here. That's an implementation. Two currencies come in. We check that the currency blah blah blah, that it's not that's not the same currency. And so we are saying at least one currency must be US dollars, and then we are making an instance of this class. This one is from JCabby HTTP, which is an HTTP client, which after this fluent configuration is going to make an HTTP connection to this URL, send in some, authentication parameter, and then parse back the JSON and return the JSON which is there. And then we use that JSON and get the quotes from there, and then we return the double value which is provided by the platform. It looks good so far, but this one is really expensive dependency. So this class is untestable right now. I cannot really write a unit test for this class. Actually, I tried, but as you can see, I only managed to create an integration test, which is, the difference between the unit test and the integration test. The difference is quite small, and it's really very often it's difficult to say which one is unit test, which one is integration test. But in this case, it's definitely integration test. So integration test is a unit test which does not break all the dependencies, but still leaves many of them there and relies on their existence during the testing. So here's the integration test. It actually makes a real connection to the production server, and not this one. This method is, you see, I need it here because the integration test cannot work if the network is down, for example. If I'm offline, if I'm running it on my laptop, and I'm disconnected from the internet, then the test will definitely fail. And that's why I added this extra method, which is annotated with the before annotation for JUnit, in order to check that we are actually online. So it tries to make a simple connection to some website, and if it's false, if there are any exception there, then it says assume true false, so meaning that don't run the test, just ignore it. And then I put this ignore annotation later just to turn it off, because it's not really stable and it takes time, and I need to provide production API code, because look, this class also needs a key, an access key, which I don't want to keep inside the production database, the code base. So it's a lot of hassle. That's my point. So running this class and testing this class is difficult because there is a dependency which I cannot break. Look, it stays right here. The instance of this class is made right inside the methods. So from the outside, I cannot do anything with that. I cannot tell this class not to touch the network. I cannot tell it to do something else, to not touch the network, maybe use some, fake data, or use some mock implementation of this API. Do something with that, but don't touch the network. It's not possible to do. No matter what I do, the moment I call this method, the network will be touched. This makes the class impossible to test. And who is guilty? The operator knew. That's my point. That if you look at the code, if you see the operator new inside the method, then something is wrong. Then it's a potential problem for testability. Of course, not every method new is a potential problem for testability. For example, look, we have a method operator new here as well. But we don't want to, it's impossible to imagine the situation where we actually want to change the exception which is thrown here. So say I want this class to not throw the illegal argument exception, but throw something else. But it may happen, we may want to do that in some future. And here comes the problem of reusability. So for the testability, we don't want that. We just catch the illegal argument exception. For example, we want to check that if you provide two currencies, then the exception will be thrown. So what do I do in this case? I create a new test method, and I say no USD is no good. No USD. Let's say no USD is not accepted. If there are no USD, the quote throws an exception. So I'm doing something like that. You see, it's still the same class, but I can see, let's do it this way. So if I ask for a quote, I expect the exception to go out. Let's run it and see. Sorry, it takes a bit longer. So we have to, you see, because the test is ignored, because the whole thing is ignored. Wait, why it's not expected is true? You see, it just doesn't work because this URL. Let's remove it, this before thing. So we're expecting illegal argument exception now, yeah, like this, and we can say that the expected exception is illegal argument exception. So now we're just testing this initial validation in front of the method. See, it works. But for the testability, it's okay. For the reusability, we may want in the future, say that, I don't know, in some other place, in some other library, I may say, I don't like illegal argument exception to go out. I want IO exception, for example, or something else. And we can't do that. So this class will always throw this particular type of exception. It's not a big problem, but it is a problem for usability. The big problem is here. Here again comes the operator new, and the problem here is very big because this class is expensive. Not the class, but the resource it represents is expensive. Way more expensive than the CPU, way more expensive than the memory. And we can't afford it to leave it here like that for the unit test, because every time the unit test will run, we will make a real live connection to some exchange, some currency exchange server, get some rate, blah blah blah. Eventually, these guys will probably have something against that. They will start banning us. They will start trying to do something with this testing. If we run tests frequently, then that's going to be a problem. So we don't want that. We don't want to touch. We don't want to touch expensive resources while we're testing. Now I'll show you how we can resolve that. But my point is that every time we see operator new, it's a potential situation for a future problem. So in ideal world, which is a utopia, it's not possible to achieve that ideal world. Definitely, I'm warning you. So don't take this whole webinar as a suggestion to get rid of all operators new in all your methods. It's not possible. You will not be able to do that, and it's not necessary. What is necessary is to remember that every time you use operator new, you have to think forward that potentially, maybe in the future, you will need to remove it from here and move it to the constructor. So the only right place, the only legal place for a new operator, for the operator new, is the constructor of the class, or constructors. There could be many of them. Because when this operator new stays in the, I'm talking about secondary constructors. You know, there's a difference between the primary constructor and the secondary constructor. So this one is, for example, this one is a primary constructor because it takes something in and stores the incoming values into the internal attributes, while these two guys are the secondary constructors. They are just using operator new, they are creating some objects, and they call the primary constructor. There is an article on my blog, just Google for primary secondary constructor on my blog, and you will see an article explaining that. So I was saying there that a properly designed object, a properly designed class, always has to have one primary constructor and a number of, or a big number of secondary constructors. And quite often the primary constructor is private, because well, in this case it's private because we don't want anyone to encapsulate it like that. So we always want our clients to go through secondary constructors. So what I was saying is that operator new has a very legal place inside secondary constructors, but not inside the methods. So here, for example, if I would want to, if I would be interested in, for example, getting rid of this dependency, then I would need to encapsulate it and then move it to the secondary constructor. Let me show you the example here and you'll understand what I'm talking about. So that's probably enough with the theory, and let's move to the practice. So so here's the problem. We cannot test this thing because let's try it and see how we fail miserably. Let's remove this. Let's say we do blah blah blah, and then we say that currency exchange euro to USD is greater than 1 0. Let's run it, and we will have some problem. Most probably the API will reject our request and say that we don't have permissions. So look, first of all, it takes time. So we're actually making the connection. There's some null pointer exception. That's weird. Oh, there you go. So most probably we got an answer which was, for some reason, it had the HTTP OK, but the object which was returned, let's see what we got from there. Let's run it again. I'm just curious what the API is telling us. Most probably there's a JSON with some error inside, but not the actual rate. Yeah, you see success false, error code 101, missing access key, you don't not supplied, blah blah blah. So we didn't give them the key, and that's why the API says sorry, can't do anything. And I don't want to put the key here. I don't want to put any key in here. I don't want to touch the API at all. I want to somehow, mock this connection. So what I'm doing is I'm introducing a constructor which will encapsulate the request. Not that one. So I'm making it now it's still a dependency, so we still depend on some request, but now this dependency is breakable. That's it. So I didn't touch the functionality. What I did is I moved the operator new from the methods. It was staying here, remember? I moved it to the secondary constructor. That's all I've done. So now the test is still the same test. Look. But I can now use this constructor for the test and inject something which will not be a real request, which will not be a real, something which is expensive, but I can inject a mock version, a fake object, a fake version of the request. Let's try it. I'll make a new JDK request. I don't know, some fake data here, and let's see what happens. We just want to see now that it will not touch the API anymore. It will not go to any third-party resource. It will just crash, but here locally. It has to crash, right? Because there is no such thing as local host on the port number 1. Yeah, connection refused, you see? So now it tried to go to look at the URL, failed get request to this address, and it failed. That's exactly what we wanted. So now the first step, we broke the dependency. We don't depend anymore on expensive resource. But when somebody will want to use the production version, they will just use it like this. And this constructor will create an expensive dependency. So now we have two options. We can use the default constructor, or we can go with we can even do it like this here, because we may say like, look, we don't want our customers, like outside customers, to use this constructor. Only we can use it inside our package. So by removing the public modifier, I make this constructor accessible only from inside the package. So meaning from the test. So from the outside, if you, for example, deploy it to your users, if you make the class like this, then your public users will only see this class and this constructor, only one constructor. So they will not be able to break the dependency. But I think that it's a good, it's a good practice to let your users break the dependency in any possible way. Actually, in general, the more constructors your class has, the better for your users. I think that properly designed objects in object-oriented programming, they must have a few methods, 1, 2, 3, maybe 4, and a huge number of constructors, like 50 constructors. So to give you an ability to use it in any possible different way, to inject all the possible dependencies, to break any possible dependencies. So let me see your chat. So there's people saying that, yeah, you can read it too. So composability. I like the word that too. Let's call it composability or usability, testability, whatever. So let's make the next step. I'll show you how we can actually complete the test. Let me find one class I wanted to copy. So we can create a fake web server. We can create a fake web server using takes framework. So what I'm doing is I can say like this. This is JSON, and so this is the front. This is the web front. It's a text which says hello world. Then I want to run this application on a random port, random TCP port, and then do something while the application is running. For this scenario, we have this class called FT remote. So it's FT stands for front, remote it's remote. So remote means like remote control. So we run the application. We can call it take. Take is like a page or something which we can see through the web. Home here is the URL of the running web server, and here we put our test. So that's all we need to do. That's it. So now we have a running web server which will be up and running inside this this function. It's a functional interface here, and inside this function we execute the Hemcrest assertion, and inside that we provide this URL into the JDK request and make it do the work. Let's improve this class a little bit more. So let's say I don't want to give you the request all the time. I want to have an ability to give you the URI. I want to make this class even more, easier to look. I'm introducing the secondary, a new secondary constructor. There you go. And here we fix it like that. So now it's even boom, 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 boom. Now it's even easier to use the class. We can provide the request, we can provide the URI. We can make this one like this. So if you want if you want us to use a different API, just give us the new URI. If you don't want to use URI, if you want to use a string, okay, we can give an ability to use a string. You see how many more constructors we have? 1, 2, 3, 4. Just one method. Still the same method, but I'm adding constructors to make the life of my users easier. The more constructors I have, the better. Because that means flexibility, that means usability, and that means composability, of course. But the methods, the amount of methods has to be very small. 1, 2, 3, 4 is a total maximum for a properly designed object. But the number of constructors can grow and must be as, you must have as many of them as possible. So now we can here, instead of JDK request, just say home. See, the code is pretty small. It has to work, but most probably hello world is not gonna work because this is not JSON. So let's run. There has to be some problem now, some exception. I don't know exactly what will fail, but let's see. Most probably it's not going to parse the JSON. Yeah, you see JSON parsing exception, hello world. This is not JSON, but it works. So we made a connection to the real server and we got the hello world from there on some port. You want to see what the port? I can show you here. So this home, it's a URL, the URI of the running web server. Okay, you see, that's the address. HTTP localhost 53510. So this 53510, it's a random TCP port which was allocated automatically by this class. So it found a free available port, TCP port. It started a real web server, and that real web server knows only one thing. It just returns hello world, no matter who is connecting, no matter what are the headers, HTTP headers, no matter what. It always says hello world. It's quite simple and quite powerful framework. It's called Takes. You can check it at takes.org. So the next step would be to actually make the real JSON, right? So how about we say it like this? I don't know what it needs, but let's check what the API returns. Let's say, so we need quotes and then source and destination and then double. Okay, so I guess it's like this. Quotes and then JSON number. Okay, so it's like this, I guess. We are checking euro to USD. Let's say 1.23. And then we can say equal to 1.23, right? So this one looks like JSON, which I expect those third-party service to return. We don't, well, that's how the code is designed. So we're faking it. We're faking the third-party API, and we run it to see whether it works. Null pointer exception here. Big get JSON number quotes, get JSON object quotes, get JSON number, source and destination. Source and destination. So for some reason we're getting null from, I guess, from here. I don't know, maybe I need something like that. You see, I'm experimenting. I've never done it before. Let's run. No, same story. Any ideas? Anybody knows what's going on? Why this get JSON number returns? Well, I don't think, maybe, I don't know what's, so let's try step by step. Let's do some debugging. Let's see what get JSON object returns. This one. Yeah, you see, it works. So it gets the JSON object, and then it says big decimal value. Why it doesn't return the? Okay, let's debug this one. Should be null, I think. Yeah. Let's see what this says. Returns the JSON number as a big decimal. The JSON number. Okay, let's try just a simple number. One is a simple number, right? Has to work. Still the same. I need your help. No, I do have quotes field. I just checked it. Quotes returns me this thing. Maybe this one is wrong. Oh yeah, I think so. That's right. Yeah, you see, it's the other way around. So look what's happening. We are, you see, it says if blah 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 equals to USD, then, and otherwise it's a recursion here. So it calls itself swapping the parameters. So for USD euro, we need a different different JSON here. It's not euro USD, it's USD euro. 123, and here it's going to divide it. I think 1 will be divided by this value. Now I guess we're going to crash on the assertion, but the JSON will work, I suppose. Yeah, there you go. You see, so it's not 123, it's something more complex. So let's make it easier this way. Yeah, 0.8. See, now it works. Beautiful, huh? So what we have now is a very good, properly stable unit test. So it's not anymore an IT case. You see the name of the test. It's called IT case. This is for Maven, for the Maven plugin. So normally you name your tests with the suffix test, but if you call it IT case, then it's not going to be executed by what's the name of the plugin? Surefire, and yeah, there are two plugins for Maven. I don't remember the names. The one runs unit tests, another one runs integration tests. So they are being executed on two different phases of Maven cycle. So we can perfectly rename it to the test. So it's okay to run it together with all other tests, because it does not depend on any resources. Well, actually it does depend on its own resources, still depends, but the resources it depends on are way cheaper now than the one we had before. So now we still depend on the TCP, on the network. So we, for example, reserve a network port here. So the TCP port is being reserved by this class. And if you, for example, run this test and all of your TCP ports are reserved, or the operating system will not give access to them, then of course this test will fail. So it is mocking the real TCP connection to the public API, but still this dependency is not, it's not an ideal mocking, but it's way better than what we had before. And look, we have another integration test here, which also was designed. You see this cache IT case. So this integration test also was not a real unit test, was the test with dependencies which were not removed. So we can turn it into tests as well. We don't need this integration testing here anymore. Cache test already exists. Okay, so we have it already. So let's then just copy this method here like this and remove the integration test entirely. So we want to test it with compares monetary values using Google quotes. You see, it was Google before, using API. Let's call it this way. So here, look, we're using an object, the same object we were testing before, and this is still a no arguments constructor, which, as we remember, will create an object connected to the real API. We don't want that. We want the fake one. How do we do that? We do something similar to what we've done here. So we copy this code. We go in here. We do it like this. And then this assertion goes here. Like this. Right? Yeah, that's correct. And we give the home here. But now I'm not sure what's going to happen with the numbers, because here is dollars, this is euro, this is Japanese yen. I don't know. We have to check. So let's run it and see what's going to happen there. I mean, I don't know what's going to be, what it will be looking for inside JSON. So most likely we're going to have null pointer exception. Oh no, see, it works. That's nice. Yeah, so we are converting USD to most probably euro or something like that. Is it true? So we create cash, $7. We add 11 euros. We say that for conversion, please use this class. And then we say compare to this one. So in order for this compare to work, we need to convert yen, Great British pounds, euros, USD, all of them. Oops. Let's check. Well, it works, which is great, but I'm not sure. Let's see all the requests which are happening there, just for out of curiosity. So we're, yeah, how do we do that? The decorator, right? So we have these quotes, we want to see what's going on, we want to see every single quote. Let's introduce a new class. Let's call it logging quotes. You know how it works, right? So we want to see what's going on, we don't want to debug, we want to see something nice. So let's see logging quotes. Let's make it. Logging quotes, which implements quotes, which encapsulates another quotes. Just one primary constructor. Boom, quote. So what do? We have this origin quote src destination, double rate. There's an exception here. And then we say from here to here, from src to destination rate. Nice. So now we have a decorator which we can use. Let's make it local just for this package. So we don't want anyone to touch it for now. The quotes that logs every single operation. That's probably version 22. Let's go. Where was it? Here. So we want to see what's going on. What I'm doing is logging quotes. Now we run it and we will see how many times it will do the conversion. Zero. Okay. Let's check that this logging quotes actually works. Let's put it here just for fun as well. Maybe it doesn't work. Yeah, the logging quotes doesn't work. I think that that's the configuration of the log4j, which is somewhere here. So we put, yeah, because only the warning level is turned on. So let's put info to see the logs. Sorry. Yeah, let's check it first here because we definitely know that this test works. So let's make sure that logging works. D, oh, you see it works, but D is not double. What? Are you sure? Rate, double, D, what's D? Okay, F, sorry about that. Running again. Yeah, you see the line from euro to USD 08 blah blah blah. Okay, let's try this one, the test, which is kind of weird because here I'm expecting a number of requests. I'm expecting like questions about dollars to euro to Great Britain pounds, from euro to USD, only from euro to USD. What about Japanese yen? I don't know. Maybe it's a bug somewhere in the class, in this cache class. I don't know why it's not checking for the Japanese yen. So how can it actually compare dollars to Japanese currency without checking the rate of the Japanese currency? I think it's a bug, which I will try to fix later. But you got the point. I'm finishing my story about dependencies. The point is that the operator new was the trouble. So here in this class, we had operator new standing inside this line, and in order to move it outside of the method, we had to introduce 4 new constructors. We can introduce even more. We can make the life of our users even easier, and ourselves as well for the testing. So the point, I'm looking at your questions right now. Yeah, there are somebody saying that there in dependency injection containers could be used for that. It doesn't matter what exactly you use, but what matters is that you try to minimize the amount of operators new inside your methods. The less you have them there, the better for your customers. When you have classes like that, where there's one method, one constructor, and there are many new operators inside your method, that is most probably an indicator of a potential problem. So you try to get rid of that. Of course, simple utility, not the utility classes, but utility objects. So objects which are just get born, they do the work, and they die. Or they're very, very primitive, so they don't really stay connected to expensive resources, like I said. So the more expensive resources are, the bigger the necessity to remove operator new from your methods and move them to your secondary constructors, not primary constructors. The primary constructor has always be free of the new operator. Always, like you see here, there's no new operator in the primary constructor. This is the primary constructor. These guys, they're secondary, so here's where you use operator new. This one is also operator new. I guess it's like this. Yeah, but there's exception. So actually all of them, all secondary constructors, they have in some way operator new. This one is also operator new, so this is actually like this. In reality, what's happening is the new string. I'm showing you that that's always a new operator here, here, and here. So when you see, it's a good, not the good, but the only possible design, the right design actually, of a secondary constructor is to have this call, this, and then new, and that's it. So if your secondary constructors look different than that, if they have some code here, that's also a problem. It's also no good. So that's a right, correct, good design of secondary constructors and the primary one. But of course we don't need that because it's Java, so we just say like that. Okay, that's all I wanted to say. Thanks for listening, and try the network I touched today. So first of all, it's a Takes framework which I was using to make this fake web server. You can also check the Cactus framework, which I was using to show you this input off, input stream off, and something else. And this code base which you're looking at right now, it's Xerocracy.com. You also can check that platform where you can work as a freelancer, or you can host your project and let us manage it. That's it. Thanks for listening. Bye bye. And see you the next Wednesday. We have webinars each Wednesday at 11 in the morning Pacific time. Bye now.